Good morning, everyone, and welcome to our fourth episode of STUDIOI Talks. How are you today?
Good. Good morning. How are you?
Good morning. Usually we came here to talk about design, but today we are going to talk about something else, not only the form, the space, the materials. Usually there is something that we cannot see in the final render, that is the engineering. So today I'm very glad to be here with my colleagues. So if you can introduce yourself.
Hamza, lead mechanical engineer.
morning.
I'm Abdelmegeed, associate structure engineer.
Good morning.
And good morning. I'm Saryas, associate architect.
Very good morning. Welcome and thank you to be here with me today. So today we will explore about this invisible layer. So how engineering help design to be more creative, to go higher, how early collaboration between design and engineering improve the outcome of the project, and also why not we will be talking about the lessons learned and how to implement it in the next projects. So if you're ready, we can start. And why not? I always like to start like breaking the myth. So some people always say that the engineers come to the room, and you can say if it's true or not. Engineers come to the room to say, no, that's not possible. We cannot do this. Let's change. But I think that at the STUDIOI we have the capability, and we are very lucky to have engineering with us as long as the design. So we work together from the day one. So I would like to know what people usually don't understand about engineering. Why is needed to be there? Amer?
Yeah, actually, it's a myth. Yeah, that the engineers are the no guys. But I see it that way. That it's always about the laws of physics. Engineers always follows the laws of physics. That's not always funny. Sometimes the concept guys think that we are going to ruin the party, putting some giant columns inside the areas that they don't like to see or something like this. But I see that we are restricted. I'm talking about the engineering, of course. I see that we are restricted by the laws of physics, as I said, that we have some codes and things that we must follow. And we need to make sure that the building, the design intent that from the concept side is preserved. And we need to make sure that it's sustainable, it's well developed and designed from the engineering point of view.
Okay.
Yeah.
And what do you say that the engineer has the greatest impact into one project?
I think when we are involving the engineering side from the beginning of the project, early stage of the schematic sketches, so this can really help at the design to more improved. Maybe the design, sometimes the designers wants to have the spaces without the columns so the structure can guide, or maybe we need some areas. I mean, we are the designer thinking about the efficiency, so MEP can guide all these things. So involving all the engineers within from the early stage, it would be very helpful for the whole design process.
For the final outcome, right?
Yeah.
And is there any pressure? Because, I mean, it's true that sometimes everything goes to the design first, right? So we forget about this. So what kind of pressures usually engineers suffer that the design guys don't see?
I think it's a crucial stage while the concept is working on a building concept. And sometimes, I'm talking in general, sometimes they are not referring to the engineering. Because, as I said, sometimes the engineering is the party pooper, as we say. Sometimes they have it like we cannot go to the engineers right now because they will ruin everything. But we have requirements. We have requirements that should be respected because as far as I know, that the concept is always thinking that we want something like it looks cool. Sometimes they want a cantilever like an 8-meter concrete, and I wanted to, but it's not feasible. Yani, by calculations, by the requirements that we have for the buildings. I want to add one more thing regarding structure specifically. We had or we have hard time with the authorities discussions because of restrictions that we have in the codes and regarding the work in the UAE.
Requirements, they keep changing.
Yes. So sometimes we cannot be that creative. It's not about creativity. We can do it, but sometimes you are restricted by what I said before, like law, physics, seismic requirements, wind requirements, and so, and the soil sometimes.
But at the end, as I mentioned before, we have design, we have all the disciplines, architecture, landscape, ID, and we have all the engineers as well. So how can we approach this in a different way from other consultancies that they don't have this capability?
Actually, the interacting between all these disciplines, which we have it in-house, is really easy for us to get the requirement from the beginning, even the limitation or restriction from the law, from the authorities, whatever it is. If we're receiving, as an architect, receiving at the early stage, so it can smooth this process more easy. And then, so interacting, having lots of meeting, even from the schematic stages, can really solve the process, the issues that might happen at the late stage or at the detailed design or sometimes on the construction. So the building will be more buildable. We can think about all these issues from the beginning, and even we can, making decision from the early stage can help even on the cost of the buildings.
And sometimes I hear, I'm going to the office and I heard there is some problems. It's always like, no, it's because of the engineering.
Yeah,
is that true?
That is true.
Yeah,
They are pushing us. They can, yes.
we don't deny it. Yes, it's true. Yeah, but engineering is about solving problems, actually.
So you are like the parents, actually, of design, right? You are there to solve the problems, to say no to the kids that they want to go higher and all these things.
They always say no.
We always say no after trying. After trying. As I said, that sometimes it doesn't work. Sometimes the nature of the structure itself, the budget of the client, sometimes it does. This doesn't allow to have unlimited budget.
Yeah.
I can make as I said, I can make a cantilever, like a long cantilever, but it will be a special system. Then the client doesn't include this in his cost or something like this.
So, we are joking, right? Like about this engineering, it's always like kind of restricting the design, but I don't think that's true. I think we don't have to see the engineering as a constraint. I think it's like enable that help us to create more, I would say. What do you think?
Oh my God. As I said, when you know what will be the difficulties or what is all these restrictions from the beginning, it's really helpful that you can manage your design to the way that solve all these problems. But in terms, when the project goes to the end, and then you figure it out what the issue will be, what is the problem will be, or what all these restrictions are, so you cannot solve it. You should cut the design, you should cut the tail to solve the issues. This is that is important, really, to understand when to understand about the restrictions.
And for example, but when this collaboration happens at the first stages, maybe, for example, for a structural, maybe it can help the design, because maybe we have like an idea or something or what to design, but we don't really know how to do it. So maybe, I don't know, going to the structural department, you can give different solutions, different ideas, what can it be done, what it cannot be done, but maybe it can help to create something that maybe the architects didn't think about that.
That
at
is
the first
true.
point.
Yeah, that is true. For example, when I'm thinking that have a long span, when I'm going to the structure, or when I want to have a design with a height, with a full height, when I'm going to the MEP and know about their requirements, I will figure it out how to solve or see those requirements. That really helpful, that they can guide us as a engineering.
So it's not limitation, it's solutions,
Yeah, so
right?
you're trusting the structure, huh?
Sometimes.
I have the feeling that I'm gonna see some blood here too. It's good, I like it.
That's always.
It's always this friction is actually it's fruitful, and sometimes yes, when concept design engineer, when he's know how to test the limits for the other engineers, I think this is part of the experience. If he's experienced enough, he knows where to go, where is the boundaries, what he can ask from the engineering structure, mechanical, what the client wants, what the design will look like after this. And I think we already been tested in some projects inside STUDIOI, and the engineering done well, as I see. Yeah.
And what would you say is the engineering between structures, mechanical, or MEP, between structures and MEP? Which one is the one who helps more the design, or on the opposite, who restricts more the design?
Maybe the structure facilitates the design concept first.
Like to create the
the
shape,
full
let's
picture,
say.
the design intent that the designer wants, and sometimes taking into consideration the mechanical requirements also. For example, the type of slabs, the framing system, because the mechanical, of course, needs some space to have the routing and everything. So I think we are stepping first in the project, Hamza. What do you think?
Do you agree?
Yeah, I agree. I totally agree. Like, the designer, as I told you, he's consider and about the external looks and how the building it will be in front of the client, in front of the end users. But it's better to involve all engineers.
All parties.
The function.
Yeah, all parties since day one. Because sometimes the designers doesn't have an idea about this system, how it will be work. This space, how it will be cooling or heating, or how the upper floor it will be drained to outside, or the stormwater system, how it will works. So if he has all these requirements since day one, he can create something better than what he are working currently, because the project without engineers inputs, it will be, I will not say useless, but it will destroy it at next stages, because the requirements, it will take more spaces, it will require maybe more heights. So all this, it will affect the design.
I can see that at the end, like integrating all the engineering at the early stage, it will give us the advantage of not having that much redesign in the future, not wasting times, resources, effort, etc. So because there is like a trend, I mean not a trend, but many times with our clients, they like to have international architects because of of the name,
Yeah.
their capabilities, of course, and they are great on what they're doing, but not always they know the requirements, the local requirements, what we need to comply, what is possible to be done or not. So what is happening when we start working, for example, on a schematic onwards, when we receive a concept design from somebody else, not ours, and what is happening, what kind of problems we are facing, and how can we try to solve them without affecting the design that much?
We had the same issue in a project that we had. The concept was outside of STUDIOI, and it was an international firm.
Don't say the name. Huh?
No. It was a respectful international firm. So we had to take the concept that the client is already accepted, and he was convinced about this concept, and he actually sold the units for this
That's
project.
a big problem then.
A big problem. We had to deal with all of these inputs while we are designing or redesigning the building. First, the architecture has had to step in because of the requirements, as you know, and UAE is different. It's not that everyone is aware regarding the requirements in the UAE, especially when it's in the concept design stage. The client, I don't think the client is more concerned about how the ramp will go or how the number of the parking go. It's okay, plus or minus and so. So we had this in-house. We had to fix a lot of things. Took some time, took some effort, but we had to do it because we needed to preserve the units that's already sold.
Mm-hmm.
Actually, it was a tower, and so we had to preserve the units sold in the upper floors and try to fix the invisible floors that the client doesn't, I won't say that doesn't know about, but doesn't care about. The parking, the utilities in there in the basement and podium. So
they're not selling areas.
not selling areas in there, and he doesn't care where you put your elements, vertical elements, where you put your MAB and so. So we already fixed it, alhamdulillah, and we proceeded. It was a good concept actually, but it didn't work 100%.
Okay, and if you think that if engineering would have come to the table at the beginning, this problem
Would be far better.
far better.
Yeah.
It's still a problem, but it's better.
Yeah.
Sure. The
Be far
problem is
better, yes.
it's always happening. Yeah.
Okay, and what are the consequences? Because before we said that sometimes engineers say no, but what are the consequences of saying yes?
You leave this to me, huh? Actually, I think in any kind of career, you don't have to say yes always like this. Things doesn't go that way. Yes, meaning that you will lose your kind of perspective about something, the design that you will have, the sustainability that you are thinking of, the design that you are going to implement in the building. So you need to stick to your requirements, not to be stubborn about it. Maybe you will be flexible, okay? You can have a conversation with the concept design team and so. But saying yes to everything, it doesn't help. It doesn't help the design. It doesn't help the engineering. Because this is not the core of engineering. Engineering is about discussion. It's about coming and going, making mistakes, fixing the mistakes and so. So saying yes to everything, I don't see this makes sense in our career. Yeah.
And then I think at the end of the project, when it comes from the drawings, it's go to the site for the building, we will see the issues. I mean, while during the process, everything happened and I agreed, but with these yes comments, but in reality, it cannot be happen. So that's why I think we should think about it. In which condition, in which situation, we can agree on some elements, let's say, on some part of the designs.
Hopefully.
The tolerance should be there at all time in the design, because at site they will not design as
site is
per
real.
the
At the end, we are
the-
talking design
the
engineering. It's
virtue.
paper.
And paper it's different about the site.
Yeah, it's
When we
digital
said
tool.
okay, the equipment it can be fit with the ceiling void 600, but at site it cannot. If we don't have this tolerance at site, it will not work.
It will not work. Yeah. That's true. Yeah, because we are just talking about theory, right?
Yeah,
paper,
on paper. No, designing on
drawings.
paper, yes.
But
Yeah.
later we need to pass the
The
ball to our
the
colleagues.
ideal life. The ideal life,
and problems
everything is,
appears. No, it's good that you mentioned that, and I really like it, the idea of the discussion. At the end, it's not yes, no. It's like gathering all together on the same room and discuss how
and I
it
think
can be
even
solved.
if we said yes, we have to discuss why it's yes, why it's 100% yes, yes, but no, but there is every time there is a yes with something. There is nothing yes 100% it will be workable. Engineering it's not like that. Yes, with something will be loosened or something will gain if we said yes or no.
There is no black and white. Let's
Yeah.
say. There's grays area in between.
That's good. And now that you're talking like about decisions, that nothing is black and white, we try to, I think we usually try to test our decisions into 4 pillars, we can say. So it can be performance, cost, time, and buildability. So let's talk about performance. Let's start with performance. So how do engineering decisions affect the comfort of the buildings for later for the people who will be living there or like using the spaces?
Yeah, it's this is the most important thing, because let's say in the design of the AC system in UAE, the AC like the water, you cannot live without. So if the design it's focus only to the cooling without considering the humidity, the air distribution, the what that's called the temperature, the set temperature of the room, it will not be comfortable for the end user. Because the cooling, I can design the space and give extra cooling, but in the end, the problem will happen. The end user will be uncomfortable. Some zoning in the space, it will not be properly cooling. Some zones, it's huge cooling. So the good design with good thinking about the space and the usage of the space, it can be give a comfortable space to the end user. Also, if we are talking about the acoustic performance of the equipments and how it will be the relationship between the mechanical equipments and the space and the acoustic treatment. So if there is no acoustic treatment in proper way, the space will be uncomfortable for anyone.
Inevitable.
Yeah, we are facing this in many areas. When we go to the buildings, sometimes at the start of the buildings working, everything is perfect. No noise and the cooling performance, it's good. But the selecting of the equipment when it will based on wrong criteria. After like 2 years, let's say, you will hear the noise from the equipments. You will find the coding performance it's less than what was in the first working. So also selecting the equipment properly and doing the maintenance period at the recommended date, it's help to give the end user more comfortable space to live. And I think the most important thing the engineers should thinking about how this space it will be used, how many people will live here. I can't design, let's say, if we have like a space with living and dining, it's open together, and there is like 12 chair and 12 sofa sets for the. I will not design for 24 people. The occupancy, it should be like, okay, maybe we'll have like 10 person will live here. Over design, it's also not a good thing about the comfortable for the end user.
Yeah.
So the middle thing, give the space, the correct information and data, and give like a safe factor, but in like a realistic thing. Okay, so you can give have a space comfortable for the end users.
Okay, that's interesting. It's a very nice explanation.
Yeah, because
And you mentioned something that I think is very interesting, and it's related with the performance, with the cost. That is the selection of the machines, the specific machines, etc. So, and I think this affects when we are talking about value engineering, how that we all know, right? The value engineering at the end of it's because of the cost, trying to reduce the cost at the end. So what are the problems of using this value engineering maybe too late instead of at the earlier stages? What can happen to the design?
Okay, good question. Actually, for the designing, especially in the UAE, there is some factors that is really important and make the design a bit difficult, which is such as humidity, the weather that we have here, the heat that here is there, and also the dust. So all these factors should we consider in the design. Plus these items, there is always cost from the client side, and also, there is a budget from the client side and the time of the delivering the project to the end users. So when we are not considering all these items from the beginning, so at the end, when it goes to the site, clients or end of the project, end of the detailed design stage, the client can push us to do some value engineering, which might affect it on the MEP equipment when they see that the cost become very high over the budget. They're gonna reduce some equipments from the MEP or some areas for some items which is not visible as a finishing. But it's very important. So this kind of value engineering, when it comes to the end, it's really affected on the quality of the buildings, on the performance, and then after a while, it affected for the end users. So they have to pay a lot to fix all these value engineering. But when we know what kind of value engineering might be happen, so from the beginning we can fix all the items, issues, and then let the project goes
perfectly. And when these kind of things happen, do you try to explain to the client, okay, we understand that maybe now the project is over budget, but if you do this decision, this is going to happen. At the end, it's going to be something.
Yes, I mean, I think we had some projects that the client try to change the manufacturers from one country to other countries. So that the first side, it can be good that everything can work properly for 6 months, but not after that. So yes, when you are explaining the technical items to the client, when they understand perfectly what will be issue at the end, so we can stop them to avoid all the changes.
So we have talked about performance, cost, and also time. I think is crucial on the design and on construction. So what kind of engineering decisions or design decisions save the most time later, maybe on construction or on later stages?
I think that as we were talking before, that the requirements for every discipline should be ready once you receive the initial data for any project, any kind of project. You know that what's the usage for this project, so you should be by experience, you are ready. We will need this, we will need that, and everything should be implemented from day one. I know that sometimes the concept engineer mostly is dealing with a client, and the client sometimes, as you said before, that doesn't have any kind of engineering background, and so we are the engineering background. Our requirements should be implemented from day one, so everyone should see what's going to implement in there, what's going to have maybe it will have an effect that the client won't like. Something like wasting some area in the point of view of the client, that this area maybe it will be like let's say an FMB, something like this, and this area this is taken for the MAB, something like this. A structure, maybe the grids doesn't work, the structure columns. So everything should be integrated, requirements should be implemented, and it comes with experience. Actually, it's a very good thing that we have all the disciplines in-house, that everyone knows and have a background that maybe the structure will require something like this, maybe the mechanical will require something like this, and so on. So I think we have an idea that we are coordinating all the time. We know each other. We sit with each other. So we know the requirements. That saves us some time.
Yeah, and I think considering having into consideration all these requirements also helps to reduce the RFIs, right? While we are on construction site.
Correct.
Do we usually receive a lot? What can you tell me?
It's depending on the project.
Yeah.
Yeah, maybe it's a big scale project, so maybe things get. I'm not going to say that it's getting out of hand, but this is the nature of the project itself. And maybe in some projects, in mega projects, that you have 2 RFIs per 1 month, it's maybe it's a good thing. You are trying to minimize.
Sometimes the RFIs, it's not like an issue in this. Some misunderstanding of the design. Why you are designing something like this?
So I think it also really helps to have this experience on site while we are designing,
Sure.
because later you can really know what they
It's
are.
better to see everything built in front of you, so you have the background. And if you are involved, the designer, if involved with the site construction time, he will have a perfect experience, especially if the issue come and it's resolved at site. So he will have like a good idea how he can avoid this issue in the design.
Okay.
And I believe in addition to the Amar's points that he mentioned, for each project, we shouldn't consider only the time of the design stage. If we consider both design and construction stage together, so we can, and all the coordination when it comes at the same time in the design, so we can reduce the time of the construction. Because when we are sending some drawings to the construction, to the site, to the contractors, when it's coordinated drawings projects, so it's smooth their way. So they go maybe with the less RFI, from their side is clear what to do, how to start, how to even if there is some issues, they can fix it easily. And all this coordination can be happened exactly within the consultant during the design stage, and for sure it will reduce the process of the whole design.
That we don't need to think in the day-to-day, right? We need to think in the long term.
Exactly.
At the end, construction is 18, 24
Yeah,
months,
that's that. For example, we have some period, 3 months for the design stage, for the contractor has 2 years for the construction stage. Then when they are receiving the documents with a lot of design mistakes or design issue or uncoordinated one, so they have to hold the project. It can be delayed for the contractor. It will be come back with the cost to the client side. So all this coordination, when it happens in-house, especially when we have all the disciplines in-house, we can discuss it easily to avoid even these kind of issues on site. Sometimes we have a supervision involved with this project, so the RFIs, when it comes to from the site comes back to the office, it easily can be solved because the designer itself is in the office, sits in the office, he knows about the project and easily clarified everything to the supervision team.
And do you also go to site? For example, if there is any problem or any doubt, the designers from the office also goes to the site to check the problem?
Yeah, of course. For example, when RFI is exactly from the supervision is coming, so the main discipline or the main person who work on the project knows the full history of the project, so easily can go. And then when it goes to the site, easily by knowing all the histories, the knowledge of the project, so it can be solved easily.
Yeah,
Quickly, yeah.
Time and money. That is the
time
most
and
important
exactly
thing
time
at the
and
end
money.
of the day. And okay, and talking about sustainability, what is the impact of over designing structures, for example? You were mentioning before something about over design, etc.
Yeah. Actually, over designing is it's not the core of the engineering, because engineering should be efficient. It should be targeting that everything should be fine within your calculation, because you are going into the dilemma of having for example, the mass or the weight of the building will be so high. So you are facing a lot of issues, maybe regarding the wind itself, maybe regarding the seismic activity, the earthquake activity, maybe regarding the foundation, because the foundation will be much bigger than it should be. So going over designing is not something like it's a good thing. You can be like just cautious, so you are over designing everything. And the core of engineering is to get something that's efficient within the design limits that you have, the standards, the codes, and not over designing everything, because if you are going into the circle that never ends. Your building will get out of the budget that the client has. So as I say, that this is not part of the engineering process. Yeah.
And sometimes sustainability can be affected by the design, or sometimes can be affected by the budget that the client have. How can we try to solve this?
I think for every client, when the designer try to have sustainability for sure it comes with the more cost to the client, but this is only for the beginning. If you think about the whole cycle of the project or lifetime, for sure it will reduce. I think from the beginning or many years ago when these solar panel systems comes to the market, everyone was panicked why it's cost a lot and how this can maintain during the using of the system. But after a while, everyone now, I mean, even these days, everyone, each client is going to have these kind of things, this solar panel to reduce the electricities, for example. And then, so it's from the beginning, for sure, it comes with the cost, but for a long time, no, it can be balanced, and sometimes, for sure, it's less.
I'm glad that you mentioned about these solar panels, because that was my next question was related with the renewable energy. When we should start thinking about renewable energy, if the client wants to have it, or we as designers and engineers want to implement this, it has to be at the early stage, or it is something that appears at the end? What are the costs and the consequences?
Each building has to have renewable energy, especially for public areas, instead to take the loads on the substation of the building itself. It can be from the renewable energy source, so it can help to reduce the electrical consumption yearly, and sometimes it will reduce also the number of transformers required for the building. So using the renewable energy, I think at this time, it's not like a luxury thing.
Mm-hmm.
It's mandatory, and it should be required for all buildings.
So we have talked a lot about theory, design, engineering at the office, but I want the gossip. I want the real stories. The name, you don't need to say the names. We don't gonna get fired tomorrow.
Without names.
But tell me, I don't know, things that has happened, some projects where engineering helped to solve problems, or maybe on the contrary, that sometimes that maybe not the full coordination creates some issues, and how we solve it in the later stage.
I can remember that we received a project from the schematic that we have to start. So we validate the project. It was a residential building. We validated, then we figured that we have a lot of issues in the parking podium levels. Then regarding the height, the MEP requirements. And so what we had done, I remember we increased the height of the podium. So this is affected on the total design. Although we try to maintain the overall design, the overall form of the project, but we faced a lot of issues. I mean, I can say for especially not as an architecture part, mainly for the engineering side, we try to solve 90% of the project's issue with a lot of difficulties. So as a timing, we revise everything again, which we went back to the design stage. Then after a while, starting the schematic, and so we that was a big issue. I mean, it was a disaster. We struggled, to be honest. We struggled a lot.
Yeah.
But at the end, it came out.
At the end, I mean, the conclusion is that we suffer, we have problems, but we work on them, and at the end, everything is solved.
Yeah,
right?
we become powerful.
Yeah.
Struggling with the issues and solving the issue.
And I guess the important thing also is, like, at the end, the way of learning of people is through
Challenges.
mistakes, no?
It's through the
Mistakes,
challenges, yes.
So you can apply these things into the next one, I guess.
The most important thing, everyone in the team didn't deal with the issue like it's my mistake, it's the other discipline mistake. No, it's mistake for the whole company. So when we are dealing with the issues in that way, nothing is impossible.
That's good. And just to, because we are almost finishing the podcast, so I just want to take like some takeaways. And I would like to know, this is a question for the engineers. What would you like that designers understand about engineering? Or what would you like that they ask to you? They come at the early stages like, shall I do this? Shall I do? What would you like for them to ask you to make your life easier later?
Just a simple question. How does it work with you? This concept. I have this concept and I want it to be integrated into engineering, all the requirements. I want to integrate all your requirements in this. And I ask you that you don't ruin the concept that I have. And we understand this. We understand that design intent, that the concept is doing a lot of work. Because the concept is, as I see, is working on both ways. With the client, which is very crucial for us as a service provider, and with the engineers. So it's so easy that we can work together in early stages and have something that is representable. Everyone is satisfied. The client is satisfied and it's working. That's it.
And for you as an architect, what is your biggest fear coming from the engineering?
The column size, the beam size. That is,
The column size, yes.
yeah, these two items, that's the most fear items.
And just to finalize, we always like to finish with some advices for the next generation who's starting into this world of design engineering. So what would be
I think
short advice?
the ability to working with a team is really important. I mean, with all the struggles that we might have in the project, any project has their own issues. But when you know how to work with the team members, with the other disciplines, that's the most important thing that can make the way easier.
Mm-hmm.
I believe the teamwork is important.
Okay.
Actually, this is a good point. Adding what Saryas said. But I have a point of view of the next generations that they are far intelligent. Maybe far intelligent more than our generation because of the facilities that they have. So they need to calm down, put their feet on the ground, and just minimize the using of the AI tools and the softwares and spreadsheets and all of this, and just use their common engineering sense.
Mm-hmm.
To get back to the essence of being an engineer.
Okay.
And not everything about money, financial, going from here and there. You need to calm down, get your experience, get your feet on the ground, and then start doing whatever you want. You have the capabilities that can make you a great engineer in the future. You have all the facilities, you have everything. You have things that we didn't have in this time. But I trust them. I trust the generations come. Inshallah, they will proceed with great potential.
Good. Yes.
My advice is simply don't look to the codes as a holy book.
Okay. I thought you were going to say, don't look to the
Many engineers now look to the codes as a holy book. We cannot compromise. We cannot adjust anything.
Break the code.
Yeah,
yes.
or break the code. No, the code it's there
Guideline.
only to give you a guideline,
Mhm.
and it's point of use. some engineers build these codes, and each year we have like updates to
Revisions,
the codes.
right?
Yeah,
I agree.
revisions.
I like it. So I will keep these three concepts, the teamwork, that I really think that in STUDIOI we have a really good team, amazing team that we can work together, thinking out of the box a little bit sometimes, so not be that
No, don't
square-minded.
freeze. Yeah.
And also I think it's important, like, come back to the earth, really learn the fundamentals, and once we know that, we can be more creative,
Of course.
let's say. So thank you very much
Thank you.
Thank
to
you.
all of you to be with me today. I hope you enjoy.
Thank
And
you.